All right, warm up for today. Probably want to press pause if you're at home watching this and give it a go because we're going to go over it here. Dr. Nazar throws an unruly student from the top of KHS, 14 meters high, with an initial velocity of 3 meters per second upward. So there's our equations that kind of govern what's going on. I guess we could take acceleration, but that really wouldn't tell us much, so there's no need to. When does Thomas reach his max height? Okay, so he gets thrown off the building. The key here is that at the max height, the velocity is equal to 0, because it's changing from positive to negative. So it's 0 at the max height. So 0 equals negative 9.8 t plus 3. So move the 3 over, divide by 9.8, and we get 0.306 seconds. Divided by 9.8, yes. What is the max height? So that means S of 0.306. But I want to use 0.306, not just 0.306, but all of those decimals that come after it. So in my calculator, I'll do negative 4.9 times answer squared plus 3 times answer plus 14. That way I get the most accurate answer possible, and I know I'll be accurate to 3 decimal places. So 14.459 meters. So we started at 14, only made it up to 14.459 because he wasn't thrown up at that much velocity, so he goes up a little bit, then we start coming down. How fast is he going when he hits the ground? So what's going on when we hit the ground? What's the helpful piece of information? S is 0. So we want to find V when S equals 0. So we go grab the S equation and set it equal to 0. Hope that it factors, but with the 4.9 sitting there, not likely. So we're stuck with either the quadratic formula, or we could put it in a calculator and let the calculator do the work. Negative 4.9 x squared plus 3x plus 14. I've got other equations there because those are things we'll use later today. But that's the one I want to look at. And I happen to be on a pretty good window of looking at it, because what happens when t is negative doesn't really matter, because that's before this experiment happened. So this is a pretty good picture of what happens. It goes up a little bit, and then he starts coming down, and we want to know the time where Thomas hits the bottom there. So, whoops, not a value, but an intersection. Nope, a 0. There we go. Find a 0. So left bound, right bound, guess. So at time 2.024, 2.024, that's the time when he hits the ground. And we want to know the velocity at that time. By the way, since your calculator just found x, that's the most recent thing in there for x. So it's in there as the time. So you can use that. You don't have to write everything out. You can just use x. Or you could use answer if you do what I just did. Negative 9.8 times that plus 3. Negative 16.834 meters per second is the velocity at the bottom. And just for my own amusement, that's 38 miles an hour. So that's not good for this unruly student who got tossed off the top of the building. But 14 meters, that's 40 feet or so. That's pretty far up there. So you would not want to take a fall from 40 feet. One more thing that I don't know that we've done this in here, and you don't ever have to do this, but it's a nice check. Your calculator can find derivatives at certain spots. So second calc, value 0, minimum, maximum, dy dx. Well, that's what I want. I want the derivative at 2.024. And there's the derivative, negative 16.835, which was the right answer. So your calculator can find a derivative at certain points. And that's why you get a calculator. That's not cheating. I know that. AP Test knows that. They expect that you can use that on the calculator part of the test.